storage units for victims of Hurricane Irene. Because he wants to minimize costs, he plans to construct the storage bins in a row so that he can use some of the panels for 2 bins. Each storage panel cost $15. So if he was only going to build 1 bin, he would need 4 panels and the cost would be $60, right? Because 4 times 15. For 2 bins, he can minimize it and just use 7 panels because they're sharing this wall. So 7 times 15 is 105. And then here would be an example of 3 bins. It takes 10 panels, so it costs $150 to build. So we're going to use these examples and complete a table, the number of panels and the cost on the next page. We're going to construct a graph to show if it's linear, arithmetic, or quadratic, or something else. So let's just fill in this top. Oh, it already is filled in for you, this top row, right? So they already filled in that 1 bin takes 4 panels, costs $60, and so on. So you're going to fill in the rest of this table, and then they wanted you to graph, what is it, storage, the cost versus the number of bins. So they want you to, they already put it in the table. There's X, there's Y for you to graph it. And then see if you could answer the questions down below. It might be helpful to try to write a formula, right? A sequence formula for either the cost or the number of panels. So I'll give you a chance to start on that. Because you could read that right out of your table, right? 10 storage units is 31 panels. So then if you have 100 panels, if you were going to like continue this table, this is the thing you would stretch all the way to 100 and you would see how many bins you could make. So what I did is I actually set up my closed formula, the 4 plus 3 times n minus 1, and I set it equal to 100. So I thought about, okay, if this is 100 and my pattern is 4 plus 3 times n minus 1, how do I solve for n? So what I did was I subtracted 4 to the other side, divided by 3, and then added 1. So I did 100 minus 4, right, gives you 96. Then 96 divided by 3 is 32. And then if you wanted to get n by itself, you'd still have to add 1, which basically is that original bin built by the 4 panels. So it was 33 bins is how many you could make. So if you got 31 or 32 bins, you were off by 1 because of that idea of n minus 1. And the first bin is the 4 sticks or 4 panels. And then each bin after that is the 3. And then you could check your answer, right? Because you could do 4 plus 3 times, let's see, we said 33 bins. So if I do 3 times 32, that gives me 100 panels. So I can double check that it worked. And then here's my solving with donations. I did 1,000, and then I did my formula 60 plus 45 n minus 1. Now here you can't round up. So I got 21 bins. If you do 22 bins, you're actually over the $1,000 mark. Because if you do 60 plus 45 times, so I said my answer was 21 bins. So n minus 1 is 20. You're at 960. And if you go 1 bin too many, you're at 1,005. Is that what you said? Did you do it by guess and check, or did you use the formula? You use the table on the calculator. That's another example. So sure, in your y equals menu, you could just put in the pattern 60 plus 45 times x minus 1. Go in your table to whatever, 20 bins, count by 1 bin, and then keep scrolling down till you get to the like 1,000. So there's 21 bins is 960, 22 bins is 1,005. But you have to know how to write the formula to use the calculator. The recursive one I'm not as concerned about, but for the number of panels, it's adding 3 more every time, and you have to tell them that the first term is 4. So if you got recursive right, good for you. This is the one I'm more concerned about, is writing the closed formulas correctly. So Just gauge for yourself if you were able to do that. So you've got homework tonight on arithmetic, but I wanted to jump into